Hello guys, today we are going to start a new topic related to the implementation of the neural network in Python programming language. In order to do that, we should utilize some functional tools or library, which we call it the Tensorflow, provided by the Google company. Okay, but firstly, we need to understand what is neural network. What is the neural network, and after that what is TensorFlow, especially in the Python programming language. Okay, firstly, you may heard about the neural network, but the neural network is like kind of the brain architecture, which means that we have the central processing units in our body or physiology, as we call it a neuron, and so the information goes to the neurons, and then these neurons creates an electrical activity related to the what relates to the how much action potential coming through the synapses or the neurons, and then this information is processed, and then the resulting activation function is a new output. For example, if you want to go to the school, and so you have decided to go to the school, but in your physiology, especially in your brain, and then this neurons is triggered, and then this decision has been made by using this action potential. And so what is the neural network? Neural network is kind of a map, but this map should be utilized to describe any relation. For example, the mathematical equation or the sum decision, or any process can be modeled by using this kind of structure. Okay, and so this is simply a map to describe any relation between the input and output. What's the meaning of this? For example, if you know this equation like this one, a square plus b times x plus c. This is the second order equation relates to the output y. In here, the output is these things, and the input variable is the x, like this one. And so if you have any x in here with the coefficients of the a, b and c, and so you can generate any results related to the output. Okay, and so this may be the length of your body, and so this is the mass product change in your body, or any index related to your physiology. Okay, or this is some simple equation related to the area of the square, and then this y represents the area of the square or some objects in here. But what happens if you don't know the equation? And so suppose that if we have only the x input and y output, and so how can we relate to the y with the x input value in here? In the first case, we have the equation or the compact relation between these two x to y, and so we can create or generate x dependent y results, or we should define this term y is equal to the f dependent on the x. But what happens if we don't know this equation? And so the neural networks can be utilized to what? The absence of the formulation of the anything. Or neural network is a simple map to describe to any relation like the x to y between the input and output. And so its improvement or the loss function or the model generation is highly complex, and so in this lesson we will not talk about it. But you should know that the neural network is a simple map to what? To describe the any relation between the input and output. And so if you have the any input value related to anything, suppose that the dollar or the euro or the TL, and so you can generate the what? The estimation about the what's the current currency of your country, or the dollar is goes to the high, or dollar is goes to the what? To the low level. And so you can predict anything by using this formulation. And so how can we do that? We have the simple neural network structure in here, like this one. We have three layers in here: the input layer, and hidden layer, and the output layer. In the first place, we should assign the whole the x value or the input value to the what? To the specific neuron. These circles represents the neuron structure, like imitating the what? The brain cells or the brain neuron. Okay? And so this x is fed into the what? The input layer. And then we have the some model function or activation function in here, in the representation of the what? The mathematical formulation. And so this mathematical formulation generates the output value in here. But that's not enough, because these maps is what? To represent maybe the highly complex values or the data or the equation. And so we should add the hidden layer in here, like this one. And so if we have the any input layer, and then we can generate the what? The one results in here. But we may proceed with the what? The hidden layer usage in order to what? In order to condition to the what? Coming from this y value. What? Where is coming from? This coming from the input layer. Because if our data is highly complex, and so we need to add the more neurons like the brain structure. Okay? And so this hidden layer also called the what? The neuron structure or neuron process with the what? With specific activation function. And so this hidden layer fed to the what? The output layer in here. And so in summary, we can generate the what? The input layer in here in order to what? In order to get the whole the coming data. And so this input layer generates to the what? To some output value in here in order to what? In order to evaluate in the hidden layer structure. And so this hidden layer collects the whole information and solves its complexity, and then we can generate or fed the output layer session in here. Okay? And so we can add the what? The input layer many times in here. Input neuron many times can be added at the input layer, but the input layer must be 1. Output layer must be 1. But in order to solve the complex problem or sophisticated problem, we can create the more hidden layer in here, or we can add the more neurons in here. For example, if we have the 2 input, and so we have the 1 input layer with the 2 neurons. But we can add the 10 neurons in the hidden layer, or 100 neurons in the what? In the hidden layer. Or we can add the another hidden layer in here, which we call it the deep neural network. Or you may know the deep learning is directly related to these concepts. And so these hidden layers produce some mathematical results in order to what? In order to feed into the output layer. to decision layer in here. And so this must be equal to the what? To y in here. Okay? And so these are the general structure related to what the simple neural network structure. And so how can we create some simple generation or the training algorithm? The neural networks can be trained by using the input and output data, which we may have this data at this moment. And so, for example, y is equal to the a square x plus bx plus c. It's an equation, and so we can generate the 1000th time data by using this formulation, and then we can feed the input layer to the x value, and the output layer must be equal to the y value or the output value. And so if we have the input and output value, we can train this neural network by representing the whole relation coming from coming from this notation. Okay? And so in a summary, it's called the neural network in here, but it's highly complex in order to understand the underlying mechanism of it. And so in our lesson we will focus only these things. Okay? And so the other term is also important, the TensorFlow. TensorFlow is that it's a standard library provided by Google in order to create your own neural network structure and also train your neural network structure and predict or estimate or generate the output of your neural network structure. And so if you want to describe any neural network in Python programming language, we can utilize the TensorFlow addition in our computer. And so this is the standard library, or it's a library provided by Google. And so by using this library we can create the neural network structure with the input layer, with the output layer, or with the many hidden layers, with a specific number of the neurons. For example, 2 input can be defined in here in the input layer, and so we can generate the 10 neurons in hidden layer. And so we can add the output layer by using the TensorFlow libraries or the functions, which are written in both the C or C++ or the Python programming language. And so in this lesson I will show you how you should utilize the TensorFlow library or its function in order to create or build your own neural network. And so we accomplished a simple neural network is created in this lesson in order to fitting some data by using the input and output values. Okay? And so finally you should utilize this set, the tensorflow.org install pip in order to install the whole additions related to the TensorFlow into your Visual Studio Code. And so the install TensorFlow with pip install TensorFlow can be used to install everything related to your TensorFlow objects. Okay? Otherwise, you cannot use the TensorFlow library. Okay? And so we can create the build our regression example or neural network example in here. For example, if we have any equation in here, like this one, y is equal to what? 3 times x squared plus 5. These are the equation related to the what? Related to our dynamic or the data in here. Firstly, we need to generate the R numbers or data. Firstly, we need to add the import matplotlib.pyplot as plt in order to visualize to hold the generated data in here. For example, this func x can be given in here, and so return value x times x over 2 plus 5 can be returned at this moment. And so in order to create the data in here like this one, numpy as mp can be defined in here, and so the mp function returns to the mp random data in here like this one. And so we can utilize the uniform function in here, -5, 5, and finally the size of our data is equal to the 1000. Okay. We can generate this data in here like this one, and so plt scatter function can be called in here like this one, and plt show should be also calling in here. Okay, but why func x should be utilized like this one? Okay, and so y is our output, x is input. And so if I run this code and then our data set is created in here like this one, -5 to 5. And so these are the general specific equation related to the 3 times x squared plus 5. Okay, these are the training data or objective data in here. And so if we want to utilize this term in here, or if we want to generate any relation between x to y without using this function, we can utilize the neural network implementation. Okay. And so how can we do that? We should call or define some network structure in here. Build network. Okay. In order to create our network, we should firstly utilize the pre-processing data. The sklearn is some kind of tools in order to the model selection. And so train and test data can be splitted by using this term. And so our generation or our input data is equal to to the x, but the other terms is the y. We have all the x and y value, but in the neural network structure we can feed every data related to the input and output into the network. But in literature or in applications, we should split as the training and the testing data. And so this sklearn.model selection function, which we call it the train test split, is split this x and y value as a what? As a training data and the test data. Okay? And so, how can we create this term in here? We should define the training set x, test set x, training set y, test set y should be equal to the what? Train test split. X is the input, y is the output, and test size should be equal to what? 0.2. And so this train test split function generates the four output: training set y, test set x, and test set y. By using the what? The input x parameter, y output parameter, and test size is equal to what? 0.2. What's the meaning of this? Meaning of this is that only the 20% of the total x and y data is utilized to the what? To the test process. And so the 80% of the whole of training set x is included in here, and the other 20% of data for given to the what? To the test. And so this must be equal to the what? 80 times, and this is the 2 times. Okay? And so if I collect these terms like this one, test size, if the test size is equal to the what? The 0.5, and so this possess the whole data 50%. Test also has the 50% data of the what? The x and y value. But in applications or the implementations, we generally utilize the 0.2 or 0.3. Okay? After that, we should utilize this term, the keras. Keras means the what? It's kind of the TensorFlow library or the function or the class, including the what? The model parameter, which we call it the sequential. These are the neural network structure or the generalized template for the what? For the creation of the neural network. And so we should also add the keras layers, import dense in here like this one. Dense means that it's a neuron in our structure. Okay? And so in order to create the what? The model parameter in here, like this one, the sequential should be called it like this one. Okay? And also we can print the whole the model function in here. And so if I run this code, and then there will be no error at this moment. Okay? And so the model is also generated in order to what? In order to create your neural network structure. And so this is what the keras.engine.sequential objects is written on this page. Ignore this TensorFlow error because it's directly related to the CUDA or the multiple core usage in here. But we don't need to apply the multiple CPU usage at this moment. Okay? And so how can we create the whole neural network in here? So the sequential is given in the what? The class of sequential in here. And so the whole the parameters and the model function can be described at this explanation of this class. Okay? And so in here we have some function like the add or the what? The pop or the something like that. Okay? And so every class has own functions related to what build your neural network. in order to add the input layer to your study, and so the model dot add function can be utilized in here. Okay, and so this function has the self and layer property in here. And so in order to create your neural network layer, we should utilize the dense function in here, like this one. And so the first parameter is related to the neuron numbers. 10 neurons can be utilized in in this function body. And so the 10 neurons is created in in this dense body, but we should give also the input dimension in here. In this case, we have one variable in here, x. And so in the first place, we have the one input layer with one neuron, but we have add the 10 neuron after that as a hidden layer. Okay, and so the first layer includes the only one neuron with one dimension, and so also we add the sequentially 10 neurons in here to create the hidden layer. And also we should give the activation function in here. The ReLU is the activation function of our body, or we can use the tangential or the sigmoid function in here. Okay, but in the first place we should utilize the ReLU. If the number of the neural network or the generated output coming from the input and hidden layer is smaller than 0, and then this ReLU is creating the 0 value. But if it's bigger than the than the 0, and then the linear approximation or the linear value is transferred to the another level. Okay. Also we can add another layer in here, like this one. The dense one activation is utilized as a linear in here. Okay, and so in this state we have created to this layer structure, but we have the one input layer with the one neuron, and so the 10 neuron with hidden layer, and so one output layer is defined in here. Okay, and then how can we train our neural network? In order to give some optimization function, we should utilize the compile function related to the model. Okay, and so the optimizer is equal to the standard gradient descent, and the loss function, which is the error function or cost function, is the mean absolute error. And also we can give some metrics in order to obtain coming from this data mean square error. Okay. And so this optimizer is like the Newton-Raphson method in order to train your neural network between the x and the y function. And so you may choose any difference optimizer in here, which is the algorithm to minimize your error value between the output y of your neural network and the training data of the y value, or the real actual output. Okay. And then the model can be trained by using the fit function. In order to call the fit, training set x should be given, and training set y should also be given. And so this fit body is trained the neural network to represent training set y. with respect to the what the training set x, and so the whole input values if the training set x, and so we may expect to the what our neural network generates the training set y value in here. And so we may also utilize the batch size in here, the 3, and the epochs is equal to the 1, and validation split is equal to the what, the 0.2. What does it mean? This means that if you have the many times of the steps or the data in here, in this case the 1000s, and so the 3 times these steps finds the minimum value and add the neural network coefficients in each 3 step size, and the epochs is equalized to the 1, which means that this epochs, the every data is processed in this notation in here to the 1000s, and then the process is finished. And so if I choose the epochs equal to the 2, and then this every 1000 data is twice applied or processed in this neural network to fit the whole data. Validation splits means that the 0.2, and so all the data match with perfectly the training data. But in this case 0.2 is enough to what, to each match value which is given from the what, the output y and the training y is enough. Okay. And so if I run this code and then I'm waiting for this, and so this 2 epochs is what is created in here with the parameters of the what, the mean squared error and validation loss and validation mean squared error in here. And so what does it mean? It means that we have 2 epochs for the what, 300, 4, because the test size is equalized to the what, 0.2. Okay, and so if I change these epochs to the what, to the 10 and so if I run again this code and so the 10 epochs is what is completed at this moment. Okay, and so this is what, this is the training phase of neural network, and this is what the generalized settings related to our neural network. Okay. And so how can we evaluate our model? We can define the loss and mean square error in here like this one, and so the model evaluate function can be called right now. But with the data of the what, test set x and test set y, because this data does not train in our algorithms. And so if our algorithms is okay or is run with the training set x and training set y, and so any data which is coming from the test set x and test set y should be equals to the what, to the general match performance. Because if we train the whole this training set x and training set y, the algorithm already fit this data, but it's important to train, or it's important to test our algorithm with the unknown data in the what, in the process. Okay, and so the test set x and test set y should be utilized in the evaluation mode of these things. Okay, and so we can also give the what, the loss value in here like this one, and the mean squared error like this one. Format loss and MSE. Okay. And so if I run this code again, and so the 10 epochs is run, and so the total mean squared error is equal to what, 20, and loss value is equal to the 3.65. And what does it mean? This mean squared error means that the training data results minus our neural network results. And so we get the square of this value and collect the whole the terms and then divide it by the number of the whole iteration or the whole the values. And so this is equal to what, the 20. The loss value is what is without the scoring formation. But in order to predict or use plotting the results function in here, like this one, we should utilize the model predict body with the with the x. Okay, and so plot scatter value is what, x, y, and label is equal to what, this is the real values, and so plot scatter x and y results coming from the neural network in this case. Okay, and this is the NN values or NN results, and PLT legend should be clearer in here, and plot show should be utilized at this moment. Okay, and so if I run this code in here like this one and then the neural network results and the output, the actual results, is given on the on the one page. For example, this real values is printing on the with the color of the blues, and the yellow represents the our neural network results. And so our neural network is converging the real results, but it's not enough in this case. Okay, and so how can we improve our results in here? Firstly, we can increase the neural network the neuron number with the 100 can be selected in the input layer, 10 times higher than the first one. And so if I run this code again and then we will obtain to the to our data in here but it's it's closing the results in here, but it's not enough. Okay, and then we can also add the model at another hidden layer in here. Activation is equal to the rel. We may add this activation layer in here like this one, and so if I rerun this code and then we have the two hidden layer, one input layer and one output layer, but we may expect to to our results is much higher than the previous one. And so if you look at these terms in here like this one, and so this is much higher than the previous results. Okay, and so how can we change with the sigmoid function body in the activation level? This improvement is okay or not? We don't know. We don't know in neural networks what is the best, but we should try it. Okay. And so in sigmoid function body, the results is closing, but it's not good enough to the previous one. Okay, and so we can change this activation function in the reverse order in here. The first layer has a value and the second layer is the sigma 8. And so how can we output change with these updates? And so this not good enough in here, like this one. And so if we have these terms in here like this one, and then we may increase the epoch number in here. And so if the epoch number in here is increased, and then the neural networks may have the much higher results in here, but we don't know in here, okay? Because the mean squared error at each time is what is closing in here. It's the best results what we have at this moment. But if I had any hidden layer in here like this one, and so the mean squared error is 13 in here, and so this much higher results at this moment. And if I increase the data number in here, the validation loss is smaller than the 1 value at this moment. And so if I run this code, and so the validation loss is the 9147328, and so the always goes to the goes to the smallest value in here. And so in this case we don't have any improvements in here, but if we may have the rerun again with the same condition, and so we may have the different answer or different results in here, because in each iterations our algorithms to start in the different positions in here. And so this epoch value may not be enough to set the minimum or the best performance. Maybe we should choose this epochs to 500, okay? Because if we delete the one hidden layer in here like this one, and so the validation loss can be changed in here, maybe decrease or maybe increased, okay? And so I'm waiting for this generation in here like this one, and then we should try the whole time by using the neural networks. For example, if you create the while loop in here, and so this much better convergence in here for this equation, but you can define the for loop in here to until the condition of the validation loss is smaller than the 0.5, and so you will find the correct number of the neurons and the hidden layers at this moment, okay? And so that's enough for this lesson. I hope you have learned about what I have talked in this lesson. You should remember that you need to solve some examples in the Tensorflow example session on the internet, and so you can easily search Tensorflow examples in deep learning application, and so you will find some database to evaluate your neural network structure and to create the neural network example. Okay, have a nice day.